Hello, I am Nubli. I want to talk about introduction. A tensile test, also known as a tension test, is one of the one of the most fundamental and common type of the mechanical testing. A tensile test applies pulling a force to a material and measure the specimen respond to the stress. It measures the force is required to grow an composite or plastic specimen and the extent to switch the specimen abstract or elongated to the breaking point. Tensile testing of the composite is generally in the form of basic tensile or flat sandwich tension testing in an according which standard such test product are stress strain diagram using to determine tensile modulus. In this experiment, we believe that we will combine four things. First, the ultimate tensile strength is usually found by performing at tensile tests and recording the engineering stress versus strain. The high point of the stress strain curve is the ultimate tensile stress as a unit of the stress. The equilibrium point for the case of composite compression instead of tension is called the compression stress. Second, yield stress. Yield stress refers to the minimal stress at which a material will deform without the significant initial in loads. In other words, the minimum stress required to make a material flow in yield stress and it is a measure of the stress of the material structure. Next, a true force at maximum load. The true stress at maximum load corresponds to the true tensile strength. For most material necking bagging, the maximum load at a value of strain where the true stress equivalent the slope of the flow curve. Lastly, the percentage of elongation. Part percent elongation to a measurement that capture the amount measure and qualify the utility of the material. The material final length is compared with its original length or to determine the percent elongation and the material utility.
The equipments needed for this experiment are a universal testing machine, test specimen mild steel, vernier caliper divider, and a marker.
3.0 Safety Precaution. The experiment had to be conducted under the assistance of the lecturer or an experimental lab assistant. Number 2, hazard related with the material that are being used in the lab is always to be ignored. Number 3, appropriate protective clothing was worn that conducting the experiment. Number 3, hazard work preparation and experiment was be never performed. Lastly, students were familiar to the location of an emergency equipment such as fire alarm, fire extinguisher, emergency eye wash, and safety shower. It is better to know the appropriate emergency response product.
Now let's have a look at the theory behind this experiment. The mechanical properties of a material used in engineering is determined by the tests performed on small specimens of the materials. These tests provide very important information on the suitability of the materials to be used in an engineering project. One of the most important tests performed is the tensile test, where the specimen will be subjected to tensile load until it fails. In order that the test specimens may be compared easily, the dimensions of the test specimen and the methods of applying the load have been standardized. Examples and testings can be found in the British Standards 18 and 2782 for metal and plastics respectively. Now we'll be having a look at the procedures to this experiment. First, the specimen is placed at 10 mm interval along the gauge length. Then, the diameter of the specimen along the gauge length is measured. Now, we put the specimen on the universal testing machine and we load it until the specimen fails. Then, the load versus elongation is recorded from the recorder. Now, the maximum load is recorded and the ultimate tensile stress is calculated. Then, from the output graph, the yield stress will be calculated. Then, the diameter of the test specimen at necking is measured and true stress at maximum load is calculated. Finally, from the measurement of the test specimen, the percentage elongation is calculated. That's all for the procedures.
Hello madam, I am LISHVAARAJ, son of Shivaji Selvan from class DKM3B and my metric number is 01DKM20F1066. So now I am going to talk about the results of this experiment. The first thing is the original diameter, which is 25 mm and it is equal to 0.025 meter. Second is the original length, which is 250 mm, is also known as 0.25 meter. Next we will go is for the final diameter, which is 18.6 mm, is also known as 0.0186 meter. And then we will go to the final length, which is 250 mm plus with 5.85 mm, which is equals to 0.025585 meter. Next we will see is the elongation, which is 0.00585 meter. And next we will see the reduction in the cross section area, where the original area is 4.909 times 10 power negative 4 meter square and the final area is 2.717 times 10 power negative 4 meter square. And now we can know that the maximum tensile force is 261 kilonewton and the maximum yield force is 176 kilonewton. As an initiative to give a clear view for this tensile test, we have done two graphs. One is from the Excel and the other one is from our own handwritten one, which is the graph. And here you can see those two. So now let's move to the discussion. The first discussion, which is 6.1, is from the output graph we have to find the ultimate tensile strength and also the yield stress. So now to find the ultimate tensile strength we have to divide the maximum tensile force with the original cross sectional area. We already know that the original cross sectional area is 4.909 times 10 power negative 4 meter square. So we have to take 261 kilonewton divided by 4.909 times 10 power negative 4 and we will get a value of 531,676.51 kilonewton per meter square. To find the yield stress, we have to divide the maximum yield force divided by the original cross-sectional area and the value will be 176 kilonewton divided by 4.909 times 10 power negative 4 and we will get a value of 358,525.6 kilonewton per meter square. Under this discussion, we have another question 6.2. We have to calculate the true stress and also the percentage of elongation. To find the true stress, we have to divide maximum force with the final cross-sectional area. The final cross-sectional area is 2.717 times 10 power negative 4 meter square. So it will be 261 kilonewton divided with 2.717 times 10 power negative 4 meter square and we will get a value of 960,560.53 kilonewton per meter square. To get the percentage of elongation, we have to take the final length minus with the original length and divide it with the original length as well. Then we have to times the value with 100. So from this we have to take 0.25585 minus with 0.25 and divided with 0.25 as well, then times with 100. We will get a percentage of 2.34 from this experiment for the percentage of elongation. Okay, for the last discussion of this test, which is 6.3, we have to calculate the Young modulus of elasticity E. Usually, Young modulus can be calculated by dividing the normal stress over normal strain. But now, since we have the graph, we have used the gradient method to find the Young modulus of elasticity. So what we have to do is, we have to take the y1 minus y2 over x1 minus x2, and we will get a value of 120 divided with 3.1 times 10 power negative 4, and the final answer we will get is 387,096.7742 kilonewton meter square. So now we are moving to the next subtopic of our experiment, which is we have to discuss briefly about the output of our graph. Firstly, this graph above is known as load against extension graph. At the beginning, this graph is directly proportional to the extension produced by the load. It obeys the Hooke's law, where it states that the strain in a material is proportional to the stress applied within the elastic limit of the material. A proportional constant, also as Young's modulus, occurs at this limit. This limit is mainly called as proportional limit, where the material returns to its original position when the load acting on it removes the elastic limit of the material completely. Next, there will be a certain point where the material deforms plastically and the damages caused by it is not reversible. This point is also known as yield point. There are two types of yield point. The first one is upper yield point and the second one is lower yield point. After the yield point, the graph goes to another point, which is the ultimate stress point. It is the point corresponding to the maximum stress that can be handled by a material before failure. It shows the maximum strength point of the material that can be handled by the maximum load. Finally, the point of failure took place at the point of the fracture and the breaking point occur. This shows us where the failure of the material will occur. So now I will pass to my friend to continue with his slide. Thank you.
Tensile testing is a way of determining how something will react when it is pulled apart when a force is applied to it in tension. Tensile testing is one of the simplest and most widely used mechanical tests. By measuring the force required to elongate a specimen to breaking point, material properties can be determined that will allow designers and quality managers to predict how materials and products will behave in their intended applications.